We're going to take a look at graphing square and cubic functions in this tutorial. And we're going to look at their base functions first and a little bit about how what happens if we multiply them by a constant. And then we'll take a look at what it means to translate any function that is a square root or cube root function off of those base functions. So let's start with our basic square root function. Okay, our basic square root function it should be a familiar term from previous classes, but let's just go ahead and take a look at that. So if we take a look at a function y equals x and take a look at a couple of values of inputs and outputs, this is just our y, our couple of different y's. We're going to look at this in the table of values. We need to be careful about what we put in for x so we can avoid decimals. So I'm going to, of course, put in 0, and then I'm going to put in 1, and then I'm going to put in 4, and then 9. Why? Because these are perfect squares, and then our function, y equals the square root of x, we can find out what those values are. The square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. And now this is the positive version, okay? So we're just looking at square root of x. If I want it negative, there'll be a negative in front of it. So let's just plot these points really quick. Okay, there we go 1, 1. We go 4, 2. Okay, and 9, 3. Know these points. Know the shape of this graph. Okay, it's your duty to know those because over 1, up 1, over 4, up 2, over 9, up 3 will really help us do that. Now I want to try to amplify this, okay, and take a look at what happens if we put a 2 in front of that. We're just going to double everything, okay? This becomes 2, this becomes 4, this becomes 9, okay? And these are our outputs again. So we start with the origin. We're going to go up here, though, okay? Now over at 4, we're going to go up to 4. And over at 9, we're going to go up to 6. 3, 4, 5, 6. Okay? Each value is doubled. So as we go up, each point is doubled. So we're twice as high at any point. Again, that's at any single point where it could go here, okay? Or at that same point, we've stretched it, it's twice as high. You can see that it's twice as tall. Okay? All right. So this means that we can conclude some things. First, a, the number that comes before the square root, okay, that's going to blow it up. Okay, and by blow up, I mean we're just going to stretch up and down away from the origin or from the x-axis, okay? H, I want you to look at this. It's close to x. You may remember from vertex form, this H deals with left, right. Guess what? It does that here. So this is negative, so any H is going to move to the right. Okay? So this is horizontal shifts. Horizontal shifts. And K then is going to be our vertical shifts. Okay, I've cleaned that up a little bit. Sorry about that. So we've got our vertical shift, our horizontal shift, and this A, this kind of factor of either blowing up, it's either like a scale factor, either stretching it up or shrinking it down. If it's a positive, if it's greater than 1, you're stretching. If it's between 0 and 1, you're shrinking. All right, let's take a look at an example here and see if we can't draw this out for ourselves here. All right. First, no number in front except for a negative. That negative is going to make everything point down this way, right? All negatives for our outputs are down here. So let's see what this is going to look like. The first thing I'm going to do is I'm going to grab my black pen and just remind you that we have a relationship here that looks like this. Here is our basic square root function. Okay? Now we're going to modify that. And that's what we want to do in this function here, is realize that we're just moving it around. Okay, so let's do that. Let's take this point where we know where it starts and shift it first up 1 unit right here. This one says up 1. So I know that I'm going to go up 1 unit right there. Okay. Then this one says I'm going to go 3 units. Careful. Think you want to think left, but you know this one's opposite. So we're going to move it 3 units to the right here. Okay. Now everything's going to be the same. It's just going to be the same shaped curve, but we're starting from a new point. Okay. So I haven't forgotten about this negative, but we're going to do that in just a second. Okay. So now I know I go up 1, I go over 4, and up 2. Okay. And then I would go further over in 9. So we know that this is generally this shape right here. Okay. But this negative means that everything's going to flip down. So we can actually take this guy. Okay. And I'm just going to tell it to flip down. There it is. Okay. And this is what our curve looks like. Okay. So you should sketch a curve that is from a translated origin, but then facing down. So the blue guy here is the graph of this function as just a sketch. Now we're going to look at cube root functions, and we want to carefully pick our numbers again. Okay, so what I'm going to do is take a look up here at our numbers. I'm going to choose 0 and 1 again because I know the cube root of those numbers are 0 and 1. But then I'm going to choose 8. Okay, because 8 is a perfect cube, which gives me 2. Okay, then we know that we can take the cube roots of negative numbers, so I want you to do -1 and -8 as well, which are going to give us -1 and -2. Okay, let's go ahead and see what this guy looks like before we blow it up with a value in front. So first, I get 0, 0, 1, 1, and 8, 2 is right here. Okay. But then I know I get those same points backwards, but they're negative. So -1, -1, and -8, -2 are right here. Okay. Let me see if I can draw this really. All right, not so bad. Okay. Now let's try seeing what happens when we blow this up. Let's grab a different pen here. 0, 0, still going through the origin. We're going to double 1. We're going to double 2. We're going to double -1, and we're going to double -2. Okay. So what you'll see that this does is 1, 1 becomes 2. Okay. And the 8, 4, or 8, 2 becomes 8, 4. Okay. So just as we saw before with our square root function, is every number gets doubled, but this time our curve has a back half. A cube root function has a back half, whereas a square root function does not. Let me graph this for us really quick. Not bad for a hand-drawn curve there on a pen pad. I could do better with a pencil and paper, but all right. So we can see that this a stretches it up. If this was less than 1 but greater than 0, then you would be down in this region down here by a similar scale factor. Okay. Negative numbers are going to take everything and flip it. This side up over here, the positive side up here down below, and then the size of the number behaves the same way. So we get a couple of hints or hints about A then. A is going to be our blow up factor. It's a scale factor. H and K are going to behave as they did before. H moving us horizontally, K moving us vertically. So there we have it. Our blow up stretch factor, horizontal shifts, vertical shifts in K. So let's take a look at a sample down here. Okay, and we are going to move, translate, maybe even blow up some of our standard cube root function. Okay, first I notice there's no A term, which means it's going to be standard shape. We're just going to move it. This 2 tells us that I'm going to move it to the left 2. Remember, it's opposite of this positive here. The -4 we're going to interpret directly and move it down -4. Okay, so let's see if we can do that. Let's start by moving over our kind of center point, our origin, which would be right here. So let's move it back 2 and down 4. Here is the new origin of the same curve. We're not blowing it up at all, so now we almost can forget everything else and remember the pattern. We're going to go over 1, up 1, okay, and put a dot, and then we go over 8 and up 2, 2, 4, 6, 8, up 2, okay. Then we're going to go back 1 and down 1, okay, and then back 8 and down 2, 2, 4, 6, 8, down 2, right here, okay. So I'm going to draw a curve really quick for that. And there you should see that we have the same shape curve. It's just shifted over to the left, and of course from the origin down 4 units. It may seem like it's a little lopsided, but let me just flip back really quick. You'll see that it's the same shape, but because we are cutting off this side over here, it looks a little bit shallower. But it is indeed the same shaped curve. So, to conclude, we've graphed both basic square root functions, and we've shown that we can amplify and translocate them around. And we've also graphed cube root functions. Here's our basic one in red and our blown up one in green, but we can also transform them or move them around